All right. Yes, welcome back to Analysis Robotics. Uh, Dex told me this concept of chai pe robotics. We'll be talking about recent robotic technologies, career opportunities, what all you have to learn, different things. So, yeah, I have my chai over here. And yes, let's begin. All right, robotics. Let's start from very basics and then we'll go to advanced. Uh, while talking very casually, very unofficially about regarding robotics, robotics is a vast area with different components combined. That components include mechanical engineering, electrical engineering, uh, computer science, artificial intelligence, machine learning, um, electrical engineering, electronics engineering, etc. So why I'm saying this is like robotics is a very the major con of studying robotics is that you won't be master of all these things. You won't be master of anything. If otherwise you will have to be focusing on one single thing to be a master of that thing. Robotics is like a interdisciplinary thing where all of these are combined. So while taking an example of a very random robotic project, it starts from a basic sensor. There will be a sensing module. There will be a processor which will be taking the data from sensor. It will be computing. Then it will be sending the necessary what all to do to the actuator. To the actuator, the thing which will be doing the work. For example, it can be a motor. All right. So this is the basic framework. There will be something sensing. There will be something to process. There will be something to perform an action. So that's the basic thing of a sensor matlab basic robotic system. And then the actuation, whatever fault is happening there, then the processing is again done based on that feedback. That's how normally robotic working processing system functions. So I'm not trying to create a very fancy edited video. It's just like a very live video call conference with the with the people opposite to me who are watching. Um, so I'll be keeping it very casual, very unofficial, very yeah, whatever it is. All right. So we talked about the basic framework of a robotic system, and uh, okay, I'll take an example of a sensor. Let's talk about like an IR sensor. Okay, so for example, while taking an example of a vacuum automated vacuum cleaning machine, you might have seen this thing where the vacuum cleaner moves around, a cat sitting on top of it. You might have seen this video, seen those videos, yeah. So how does this thing work? There's an IR sensor in different sides of it. This IR sensor will be emitting light, it will be receiving light back, and based on the amount of time taken for the light to travel and to come back, the distance of the object of the obstacle is being identified. Then using that data, the vacuum cleaner machine maps a rough idea about the room. If it's a rectangle room, based on this IR data, a rough map of this thing is made. Okay, so I hope you got that thing. Then by understanding this thing, this IR data values are sent to the processor. This processor will be computing uh, whatever computation to be done, and it will be sending an actuation signal to a motor and a mopping system under that thing, wherever water have to be sprayed, wherever it have to be cleaned. Okay, so it's like a basic functioning system of a robotic software. IR sensor sensed, actuation is done based on that thing. At the same time, you can control this device via phone. And this controlling to control this thing, you have to be having an internet access on the automated vacuum cleaning device. So that access will be done via a communication transfer system. It will be having various transferring various communication protocols like GPS, GPRS, kuch bhi. There will be communication protocols like 5G, LoRaWAN, LPWAN. So using those things, those different communication networks, it will be communicating those data to Wi-Fi, then to your smartphone. Okay, so that's how a basic robotic framework of a simple automated vacuum cleaning machine works. So I talked about IR sensor inside that thing. While scaling an IR sensor into a very large scale based on purpose, while doing that thing, IR sensor can be scaled. The whatever we have used right now is a 1D IR, a 1D IR sensor. It only sends signal to one point and it receives back. Okay, that's 1D. There is a 2D IR system, IR sensor. One sec. Hmm. Okay. So this 2D IR system, it will be rotating at the same time. The IR sensor will be on a rotating disk. It will be sending data to all 360 degrees, and the obstacles of all 360 degrees are being recorded based on the receiving data. Okay, that's a 2D LiDAR. So we covered 1D, we covered 2D. What is 3D LiDAR? 3D LiDAR matlab, it will be rotating and at the same time it will be sending IR signals in an angle. It will be rotating and sending IR signals into 1, 2, 3, 4. So I say point to point they'll be sending IR signals in a certain angle, and that based on that IR signal data, the entire 3D design of the room is being mapped. Okay, so that is like an advanced system of a very basic IR sensor. This 3D IR sensor is called a LiDAR or light LID. What? Oh, sorry. What is it? All right. Okay. So that's called LiDAR, light emitting distance and ranging. I forgot the full form of LiDAR, but like yes, so that's called LiDAR. This particular LiDAR system is used inside autonomous driving systems, autonomous whatever the autonomous system that you see in land. For example, agricultural harvesting autonomous robot, it will be having a LiDAR system on it in order to map whatever things are there in the surrounding and then process the path according to that. So we covered basic framework of a robotic system. We covered what is a normal IR sensor, 2D IR, 3D IR, which is also called LiDAR, and how this LiDAR is being used for a autonomous driving system. All right. So just one sensor called 3D LiDAR won't be able to function in such a fancy way. There have to be a large computation, a large entire thing behind it. The every processing is left behind it. So how does a 3D LiDAR? 3D LiDAR is just a sensor without a computational system. It will be just a crap. Okay. So how does you make it work? There comes this thing called SLAM. SLAM, simultaneous localization and mapping. So we talked about autonomous driving systems. Mapping is a thing which is done, as I said, 3D LiDARs will be scanning the entire surroundings and it will be creating data of the surrounding, the 3D data. For it will be able to capture the walls, capture the obstacles, everything three-dimensionally around it. This 3D LiDAR data is saved into a software. I'll come that into later. So the process of saving these 3D LiDAR components, values and data is called mapping. Inside the SLAM, the M mapping is called this particular part. Then comes the localization part. So the localization works with the GPS. Everyone is familiar with GPS. Right now GPS is everywhere. Inside your phone, everything. Okay. So this localization, when the GPS coordinate data combined with the mapping done by the LiDAR, When these two data are combined together, it creates a 3D visual representation of how an entire environment is working. For example, if an autonomous system is moving from one end of a hall to other end of a hall, the GPS coordinates will be tracking the starting point and throughout the travel region, and the 3D LiDAR will be mapping the entire uh, path which it traveled. Combining the GPS coordinates from one end to another end, along with the combined data from 3D LiDAR, simultaneous localization and mapping is done of the entire hole. Whatever is there in the hall, for example, there can be doors, there can be pillars, there can be windows. Everything is crystal clear 3D mapped throughout the way. After this simultaneous localization, this mapping is done, this data can be used for autonomous driving. This is basically how a autonomous driving system or anything that's autonomous works. At this point, there will be some other technical advantages, other sensors, whatever there might be something different coming up in future. But as of now, this is how any autonomous system works. Um, you might have seen driverless cars, so you will be seeing a rotating system on top of it. That's a LiDAR. That's a 3D LiDAR. Okay, so we learned about that. That is SLAM. So we combined LiDAR data with the GPS values. So in order to make this data functioning, we have to use something else called Robotic Operating System, or ROS. ROS is it's not a new thing. It's been there for many decades in the market. Many decades, matlab? Almost 10 to 12 years, yeah. Sorry. Uh, it's an existing thing in market. ROS, Robotic Operating System. This data, the combined SLAM data. This SLAM data is put up into a robotic operating system where we would be able to plan a path. So based on this thing, we can plan wherever the car or autonomous thing have to go. So when I said about a automated vacuum cleaning machine, this thing works with SLAM. It has an IR sensor. You will be able to understand the 3D mapping of that entire room using a vacuum machine inside your phone. Okay, and this functions autonomously because of an previously path planned system. So it autonomously generates wherever it have cleaned, and that particular coordinates are already being saved, and this coordinates will make the robot understand that you don't have to go there again because we have already cleaned that part. So that is the ROS and SLAM part. So you have to realize the magnitude where we started with a very basic IR sensor. IR sensor scaled up to such an advanced stage where we reached 3D LiDAR. Then from that LiDAR we developed something else. Using that thing, an entire product was born. Similarly, every single sensor and actuators there in the market have an advanced scaled up project, something like this. Okay. For example, ultrasonic sensors. Ultrasonic sensors are scaled into a thing called sonar, which is used in ships. Radar, even stepper motors that you are seeing inside printers. Everything have been developed throughout the years. So I just gave an example of one single thing that's happening, just like a basic framework, advanced project. Okay, I just said these things. Now I'll just talk about some upcoming carrier in demand things that they're in the robotics field right now. As I said, SLAM and ROS is a very demanding skill in the market right now. Another is STEM robotics. STEM is like mathematics, engineering, technical, science. So you might be having a basic idea about STEM subjects. It includes physics, um, chemistry. So you will be able to join as a robotic trainer in some schools. Like that. It's a very in-demand skills in India and in outside India. Then PLC, programmable logic controller. It's similar to a microcontroller, but like in it functions majorly in factories and in industries. I won't say it's very similar to a microcontroller, but still it is used in a very heavy duty purpose. PLC. Yeah, microcontroller. When talking about it, there is ESP32, Arduino, Raspberry, etc., etc. All right. So we talked about SLAM, ROS, PLC, and STEM robotics. Okay. So these are some basic demanding skills in robotics field. Another thing will be including communication protocols. If you are uh, because the data that's being generated in the robotic system have to be transmitted somehow in order for a user to understand. Okay, so it has to be transferred in an optimized way where battery usage should not be that much, and it should not consume that much power. It should be of very less data rate. So in order to do that, uh, you have to learn about communication protocols. That would include low power wide area network like LPWAN, LoRaWAN, 5G. So don't get intimidated by these words. If you are a newbie, you'll be able to learn all this. And yeah, these communication protocols are one of the major in-demand skills that's there in market right now. So what I was talking right now was core robotics. Core robotics, software, skills and demands. As I said, there are mechanical things, mechanical engineering stuffs that includes designing, Fusion 360, AutoCAD, designing aspects, how material handling, how a material to be managed, designing based on how material is to be used. Then this comes in mechanical engineering part. Electrical engineering part is where the current rating, how the components have to be selected in order to make a robot that functions properly. For example, if you are using a very low current rating component inside a robot, it won't function properly. Your robot might get fused, damaged. So you won't be able to do that. Yeah. So that comes in electronics part. While coming into software part, you have to learn about programming, deep neural networks, different libraries that are there in the deep neural networks like TensorFlow, OpenCV, PyTorch, NumPy. These are different parts inside the CSE, AI, ML part. So all this combined together to form an interdisciplinary thing called robotics. So my chai got very cold. I was trying my best to make it very interesting. Um, I was trying to make it a fun conversation, but when it comes to these things, it gets very serious in between. Yeah. All right. So that was a basic overview and a basic thing in Chai Pe Robotics. It's a first very experimental episode. We have a large vision and a large dream ahead of us. And thank you if you have watched till right now. Then thank you so much. Dil khush ho gaya bhai. Yeah. So thank you so much for watching till right now, and thank you for all the love that you are giving to us. Thank you for all the love that you gave for the Aishwarya's video. We got almost 650 views for that. Thank you. It's a beginning step, but still we are happy. Thank you so much. Thank you for all the love that you're giving. We will be coming up with something bigger, greater, and dream big. Anything is possible. Thank you so much.